Hi everyone, welcome back to Calculus with Jackie and Shadow. Today we're going to be talking about discontinuities when graphs are not continuous. So let's get started. So we're going to start with some examples just to picture in your mind. So imagine Jackie and Shadow are trying to get together on one of the trees that they like to hang out on, and they go towards the same branch, but that branch is broken and they can't land on it. And then the second example is, let's say that Spirit flies towards the nest tree to meet up with her mystery friend, but she ends up on a different branch. So they don't end up on the same branch. It's gonna be like Spirit is flying towards that branch, and you got that other eagle that's flying towards a different branch, but they don't end up meeting up with each other. And then our final example is Sunny and Gizmo try to meet up on the Gizmo tree, which is one of the trees that Gizmo went to after leaving the nest, and it was named after Gizmo. But they meet up there, but instead of landing on the tree, they both catch a thermal and they just go up and never come down. So, what's going on with these? These are examples of discontinuities. There are three different types of discontinuity. The first type is a hole in the graph, or a removable discontinuity. It means the left and right limits match, so the limit exists, but the y value at that limit, x value, is undefined. So that's like Jackie and Chow trying to get together, but the branch is broken, they can't land on it. They can get close to it, but they can't exactly get there. Now, a jump discontinuity is what we call it when the left and right limits don't match. So that means the limit doesn't exist. There could still be a value of the function that's defined, but it just means the left and right limits don't exist. So if you have Spirit and the other eel, they're flying towards each other, but they end up on different places from the left and the right. And finally, we have an infinite discontinuity. This is like Sunny and Gizmo going off to infinity. They don't go towards a specific point because they're going off to infinity. So we say that it's not continuous. So let's practice with some non continuous graphs. So, what type of discontinuity is this? Well, you can see we have this whole graph that's filled in, except we have an open circle, so we have an undefined value. And what type of discontinuity is that? That's going to be a hole or a removable discontinuity. Now let's look at this graph right here. So you might think that this is a jump discontinuity because it's jumping from up here to down here. But it's an infinite discontinuity because it's just going up and up without bound. And on the AP exam, there will be a dotted line in the middle where the vertical asymptote is, so it'll be more clear. But this is the Sunny and Gizmo catching the thermal sort of thing. It's an infinite discontinuity. And then what type of discontinuity is this? Well, you have this value up here and this value down here. That's going to be a jump discontinuity. It's going to be Spirit and the other eagle. Now, sometimes they'll ask you to find the location and the type of discontinuity So we're going to practice a little bit with that. So try to name every discontinuity and its x coordinate in the following functions. So the first one, we have this graph, and let's see what discontinuities we have. We have an open circle at x equals 1, so that's going to be a whole or a removable discontinuity. And then down here, we have, as x is approaching 3, we have it approaching 1 from the left and 0 from the right. So that's going to be a jump discontinuity. And then as x is getting closer to 5, the limit exists, but the actual value is different. So that's going to be a removable discontinuity. It's a single point in the graph that's missing or out of place. Now let's try this one. This one's a little harder. So we have an equation, and it looks pretty nasty. It's absolute value of x times x plus 2 over x cubed plus 5x squared plus 6x. So let's go over to the calculator to figure this out. So what will we do with a function like this? Well, notice that all these terms have an x in them, so we can just factor out an x down here, and that becomes x squared, all the powers just go down 1, plus 5x plus 6, and that all multiplies through by x. And then this is a quadratic, so we can factor it, and what multiplies to 6 and adds to 5, that's going to be 3 and 2. So we have x plus 3 times x plus 2. And now we can find the types of discontinuities. So how you'd find them from a function is if you have 0 over 0, then that's a whole, because the limit exists, but the actual value doesn't. If you have some number over 0, that's an infinite discontinuity. It's a vertical asymptote going off to infinity. And then if you have something that the left and right don't match, like absolute value of x over x, and that's a jump. And we do, in fact, have absolute value of x over x in this. So we'll take this out right here and multiply it through over here. So we know that this is actually going to have a jump discontinuity at x equals 0. And then we have x plus 2 over x plus 2. When x is negative 2, it's going to be 0 over 0. So that's going to be a whole or removable discontinuity. And then we have an x plus 3 in the denominator, but not in the numerator. So when x is negative 3, it's going to be this divided by 0. So that's going to be an infinite discontinuity at x equals negative 3. And if we turn on the graphs for these, there is in fact a jump at x equals 0, a vertical asymptote at x equals negative 3, and at x equals 2, we got a hole right there. It's undefined, but the limit exists. So that's it for today, and we'll see you next time.